Picture a fully finished apartment, tiles grouted, light switches wired, plumbing sealed, dangling from a crane above the Singapore skyline, about to be slotted into place on a 56-story skyscraper. When you see 3,000 of these identical rooms stacked together to build a tower, it is easy to assume you're looking at a brand new technological breakthrough. The practice of manufacturing a building somewhere else is nearly 2 centuries old. In 1837, a London carpenter named Henry Manning designed a modular wooden house that could be flat-packed and shipped all the way to Australia. We have rediscovered this concept roughly once a generation ever since, famously following the Second World War with a mass rollout of temporary modular housing in Britain. Yet despite centuries of being pitched as the answer to housing shortages, factory-built housing accounts for less than 5% of the market in places like the United States and Australia. This moving construction indoors is an obvious efficiency hack. The question is why it remains a marginal niche that regularly bankrupts billion-dollar startups. Prefabrication functions like a dial, measuring exactly how much of a building is manufactured before it ever reaches the construction site. Traditional builds sit at level 1, using individual components like roof trusses or concrete panels. For modular skyscrapers, they crank that dial to level 6, moving 90% of the labor off-site and into a factory. The primary reward for turning the dial that high is raw speed. Building in a factory can accelerate a project's timeline by 20 to 50%. Parallel processing accounts for that speed. While excavators dig muddy trenches, the actual rooms are simultaneously assembled on a dry, climate-controlled factory line. That parallel schedule introduces a massive structural constraint, the loss of late-stage flexibility. Traditional construction sites quietly absorb a lot of delayed decision-making. You can tweak a floor plan or route a pipe right up until drywall goes in. Factories cannot. Once a module enters the production line, every single dimension is locked. Deciding you want a different bathroom tile layout when the unit is rolling through Station 3 means stopping the entire factory or scrapping the work entirely. High-level prefabrication trades the freedom to change your mind for absolute certainty in your delivery date and price. That certainty is valuable, but it leads to a stubborn myth in the industry, the assumption that factory-built homes are automatically cheaper. A dirt construction site is a variable cost. You only pay workers and rent cranes as needed. A manufacturing plant is a massive fixed cost. It burns cash every single day, requiring a continuous, multi-year pipeline of orders to survive. This chart shows output volume versus unit cost. If utilization plummets below 70%, fixed overhead spreads, making every room more expensive than framing it outdoors. Building plants before securing demand bankrupted startups like Katera, Vive, and Ilke Homes. Even if you solve the factory math, you still have to move the product. Highway transport limits dictate the design of a modular building far more than architectural vision. Transporting 3-dimensional rooms requires police escorts, precise route surveys to avoid low bridges, overnight travel windows, and massive cranes to navigate tight city sites. There is also a hidden structural penalty. Modules have to be engineered with heavier steel connections solely to survive the extreme vibration of a highway road trip, stresses they will never encounter again once they are bolted to a foundation. By the time you pay for the extra steel, oversized hauling permits, and heavy-duty cranes, the financial savings generated inside the factory are frequently erased on the highway. Prefabrication consistently dominates the housing markets in Sweden and Japan, proving the model thrives when specific requirements are met. It works best in building types that rely on repeating a single, highly refined unit hundreds of times, like hotel chains, university dormitories, hospitals, and large apartment complexes. Conversely, a bespoke, one-off custom home designed for a sloped, uneven dirt block is the absolute worst fit for this technology. The lack of repetition guarantees you will pay a premium. For factory building to scale successfully elsewhere, local regulations have to adapt. Building codes must recognize national factory certifications, and banks have to be willing to finance construction materials while they are still sitting in a warehouse, long before they are permanently attached to the land. The long-term success of prefabrication depends on a steady pipeline, patient capital, and a regulatory system designed for factories. It is an industrial model, waiting for the right economic climate to finally take root.